So we've talked about multivariable equations or linear systems, and now we're going to take a look at partial fraction decomposition. And the first thing we need to do is fix this equation or this expression. It should be x squared plus 6x plus 8. So go ahead and fix that. And so the first thing we're going to do is factor the denominator. So that's going to become x plus 4 and x plus 2. Okay, again, we're factoring that into two linear denominators. And so then we can say, okay, well, that's going to equal a plus or over the first factor, which is x plus 4, plus b over the second factor, which is x plus 2. Okay, and so then if we multiply both sides by x plus 4, x plus 2, then on the left side, our denominators are going to cancel. So then on the left side, we end up with x plus 8. And then our a over x plus 4, those x plus 4s cancel, so we are left with a over x plus 2. I'm sorry, not over x plus 2, it's a times x plus 2. Okay, and then for the b, the x plus 2's cancel, so that's x times x plus, or b times x plus 4. Okay, so then we can distribute. So we have x plus 8 equals ax plus 2a plus bx plus 4b. And then we can do a little bit of rearranging to get our x's by itself. So ax plus bx, and then 2a plus 4b. Okay, and so then because we have those grouped together, then we know that our x is going to equal ax plus bx, and then our 8 is going to equal the 2a plus 4b. So we have a plus b equals 1, because remember, there's a 1 in front of the x, so 1x equals ax plus bx. And then we have 2a plus 4b equals 8. Okay, so then we can multiply the first expression by -2. So that gives us so we have -2a minus 2b equals -2. So then we can add those two together, and we get 2b equals 6, so b equals 3. And then we can plug that into a plus b, so b is 3, equals 1, so a equals -2. So our expression is -2, remember that's our a, was over the x plus 4 plus 3 over x plus 2, because remember 3 was our b. And that is your partial fraction decomposition. So if you were to add those two expressions together, you would get the original x plus 8 over x squared plus 6x plus 8. All right, let's take a look at number 2. Okay, so number 2, we are going to factor the denominator again, just like we did in the first problem. So we've got 3x squared minus 5x plus 5 is our numerator. We don't change that. So we can factor out an x. When we do that, we end up, if you look at that, it's x, and then it's x squared minus 2x plus 1. So when you factor that x squared minus 2x plus 1, you get x minus 1 times x minus 1. Okay? So now we are going to write out a over the first one, which is x, plus b over x minus 1 plus c. And now here is where it's a little bit different. It's not going to be x minus 1. It's going to be x minus 1 quantity squared. And you'll see why in a minute. And so we can rewrite our equation if we multiply everything by our x times x minus 1 times x minus 1, then that's going to give us 3x squared minus 5x plus 5, and that equals a times the x minus 1 times x minus 1, which we know is x squared minus 2x plus 1, plus b times x minus 1, which is x squared minus x, plus c, and then the x minus 1's cancel, so that's just c times x. So then we can simplify that sum. So we get ax squared minus 2ax plus a plus x squared minus bx plus cx. And then we can rearrange that. So ax squared plus bx squared. And then we have minus 2ax minus bx, not c, it's an x, plus cx. And then we still have our plus a. Okay? So then I'm just going to rewrite the 3x squared minus 5x plus 5. All right, so now we know that 3x squared is equal to ax squared plus bx squared. Negative 5x is equal to negative 2ax minus bx plus cx. And then 5 is equal to, oh, that should be a c. I don't know why I put 1. Why did I put plus 1 there? That should be an a. There we go. So 5 is equal to a. I'm not sure what happened there. All right, so now we know, let's fix that a little bit. All right, now we know that a plus b equals 3, and that came from the x squareds. A plus b equals 3. We also know that negative 2a minus b plus c equals negative 5. And then we also know that a equals 5. So we can plug the a into the first equation. So 5 plus b equals 3. So b equals negative 2. So now we know a and b. And then we can plug those into our blue equation, negative 2a minus b plus c equals negative 5. So negative 2a, and we know that a was 5, minus b, which was negative 2, so that's minus a negative 2, plus c equals negative 5. Oh no, that should be a 1. Oh, I messed up there. That should be a 1. All right, so let's go back and fix that up here. Somehow I put a 5 there. All right, so that should be a minus 1x. All these should be minus 1. So let's fix that. Minus x, minus x, minus x, negative, oh, I should make that blue. All right, that's why it's important to pay attention to what you're doing. Okay, so negative 1. Yeah, there we go. That's better. All right, so negative 10 plus 2 plus c equals negative 1. So c, all right, that's going to give us a negative 8. Add the 8 over. That gives us a 7. So we end up with 5 over x minus 2 over x minus 1 plus 7 over x minus 1. And you can write that quantity squared, or you can write x minus 1 times x minus 1. Either one will do. And if you add those out, find your common denominators and everything, you will find that you get the original problem. All right, let's take a look at example 3. All right, find the position equation. S equals 1/2 a t squared plus v sub 0 t plus s sub 0 for an object at the given heights moving vertically at the specified time. So we want to figure out what a, v sub 0, and s sub 0 are. So we know at 1 second, s is 75 feet. So 75 equals 1/2 a. We know that t was 1. Plus v sub 0 times t, which was just 1, plus s sub 0. Okay? Then at 2 seconds, we know that it's 62 feet. So 62 equals 1/2 a, and then times t squared, so 2 squared is 4, plus v sub 0 times t, which was 2, plus s sub 0. And then at 3 seconds, s was 17 feet, so 17 equals 1/2 a times t squared, which is 9, plus v sub 0 times t, which is 3, plus s sub 0. So there is our system of equations. And so I'm going to get rid of that 1/2 just to make it easier. So we have 150 equals a plus 2v sub 0 plus 2s sub 0. And I just multiplied everything by 2 to get rid of the fraction. And the next equation, we'll simplify that a little bit. So 1/2 of 4 is 2a plus 2v sub 0 plus s sub 0. And then the last one, again, I'm going to multiply by 2 to get rid of the fractions. So 34 equals 9a plus 6v sub 0. Remember, I'm multiplying everything by 2 to s sub 0. Okay, so the first thing we can do is if I want to cancel out my first 2 equations, I'm going to multiply the first one by a -2. So I get, oh, wrong color. So I get -300 equals -2a minus 4v sub 0 minus 4s sub 0. And then I'm going to add the second equation to that. Just rewriting it. Okay. And so then that will give us -238 equals, those cancel. So then -4v minus 2v, or plus 2v is -2v sub 0 minus 3s sub 0. Okay. And then we're going to come over and I am going to multiply the first equation again, but this time I'm going to multiply by a -9. So I get -1,350, yeah, equals -9a minus 18v sub 0 minus 18s sub 0. And now I'm going to add that to the last equation, which was 34 equals 9a plus 6v sub 0 plus 2s sub 0. All right, so now we're going to add those together. We get -1,316. The a's cancel. So we get -12v sub 0 minus 12s, no, not 12, that's a 16, s sub 0. Okay, so now we have 2 equations that are in terms of v and s. So I'm going to take that one and bring it up here. And actually, while I bring it up, I am going to multiply by -6. So that gives me 1,428. And then that makes this a positive 12. That's why I'm multiplying by -6, so I can get those to cancel out. And this becomes a positive 18s sub 0. So then when we add those, we get 112 equals 2s sub 0 because our v's cancel out. So when we divide both sides, we know that s sub 0 is 56. So then we can take that 56 and plug that back in. Okay, so now we need to take that s and plug it in to the equation where we just had v sub 0 and s sub 0. So we've got negative 238 equals negative 2 v sub 0 minus 3 times 56. So then when we do all of our operations to that, we end up with v sub 0 equals 35. So then we can take both of those and plug them into the original equation, well, the original manipulated equation, the first one. So 150 equals a plus 2 times v sub 0, which we know is 35. Oh, yeah. Plus 2 times 56, because that's what s sub 0 is. So then we end up, when we do all of the operations to that, we end up with a being negative 32. So our final answer, and we'll put this up at the top, our final answer is plugging back in the a, the v sub 0, and the s sub 0 into the very original equation in the problem. So s equals negative 16, because 1/2 of negative 32 is negative 16, t squared plus 35t plus 56. So this is the equation that can be used to find the height of any given object at any given time. All right, then we'll take a look at example 4. Find the quadratic equation y equals ax squared plus bx plus c, whose graph passes through these given points. So we know that negative 4 is our y value for when x is negative 1. So we have a times negative 1 squared plus b times negative 1 plus c. Okay, and then that will simplify to negative 4 equals a minus b plus c. All right, then we have the second point, which is 0 equals 1. So 1 equals a times 0 plus b times, well, that's 0 squared, b times 0 plus c. So that simplifies to 1 equals c. So that's helpful. And then the last one is 3, negative 8. So we have negative 8 equals a times 3 squared plus b times 3 plus c. And so that one is going to simplify to negative 8 equals 9a plus 3b plus c. Well, we can add the first and the last equations together. We can also plug in the c while we're at it. So then we have two equations that are just in two variables. So we have negative 4 equals a minus b plus 1. And we have negative 8 equals 9a plus 3b plus 1. Okay. And then I am going to simplify. We'll simplify these two first. So this one becomes, let's see, negative 5 equals a plus b. Oh, sorry, that's minus b. And then this one becomes negative 9 equals 9a plus 3b. Okay. So now let's multiply the first one by 3. That way our b's will cancel. All right, so we end up with negative 15 equals 3a minus 3b. And then negative 9 equals 9a plus 3b. So then we get negative 24 equals 12a. The b's cancel. So a is negative 2. Then we can take that and plug that into any one of our equations. Let's just move that up a little. So we can plug that into, let's go with our original. So -4 equals A, which is 2, minus B, which we don't know yet, plus C, which we know is 1. And so then -3, no. Subtract the 2. Subtract the 1. Wait, that's a -2. Ah, that's why. Okay, so it will be -3. Let's fix that over there. That's a -2 over there. Okay, so equals -b, so b equals 3. So our final answer is y equals a, which is -2, x squared, plus b, which is 3, and that's times x, plus c, which was 1. So that is the parabola that will go through all of those points, and you can check it by plugging in all of those points.